300,000 times. Just take a look at that number for a second. That's how much the computer power used for the biggest AI models has grown since 2012. It's a number so huge, it's kind of hard to even wrap your head around it, but it stands for a very powerful idea that has completely defined the last decade of AI. And that number gets us right to the heart of what we're talking about today. There's this huge tension in the AI world right now. Are we just building bigger and bigger digital brains, or are we getting close to actually designing them, from the ground up? Okay, let's dive in. So take a look at this chart. The steepness of that curve, it's just insane. This is based on OpenAI's work, and it shows that AI training compute has been doubling every 3.4 months. Now, you've probably heard of Moore's Law, right? The gold standard for progress, doubling every 2 years. This blows that out of the water. This isn't just growth, it's an explosion. And this idea is the foundation of what we call the scaling paradigm. All right, so here's our game plan. We'll start with this dominant age of scale. Then we'll get into two really powerful counterarguments, the idea that less is more, and this conceptual turn, which is all about understanding the building blocks. We'll see how they connect, and then we'll ask, what's next? So let's kick things off with the philosophy that got us here. For the last 10 years or so, the race in AI has really been driven by one simple, powerful idea. Bigger is better. And you can really see how we got here on this timeline. I mean, think about it. Before 2012, using GPUs for this stuff was kind of niche. Then, things just took off. We went from training on a few GPUs to using hundreds. And after 2016, we figured out new ways to run these massive training jobs. And that's what really opened the floodgates for the giant models we have today. And this was the core belief. The logic was just undeniable, and for a long time, it really worked. If you wanted a more capable AI, one that could write better or reason better, the playbook was simple. Throw more computers at it and feed it more data. It was all about building, not necessarily designing. This quote from OpenAI back in 2018 really nails it. They were the ones who pointed out this crazy 3.4-month doubling time. And once they put a number on it, the entire industry basically said, okay, game on. The race to get bigger and bigger was officially on. But what if that's not the only way? What if just getting bigger and bigger isn't the whole story? That brings us to this really fascinating counter idea. What if less is actually more? So let me ask you this. We live in a world where AI models have hundreds of billions, even trillions of parameters. You can think of these as the little knobs the AI tunes to learn. In that world, what on earth could a tiny model with just 7 million parameters possibly do? It sounds completely hopeless, right? Like bringing a rowboat to a naval battle. Well, check this out. This is wild. This table shows how different models perform on a super difficult reasoning test. Up top, you've got this monster 671 billion parameter model, and it scores around 16%. But at the bottom, a tiny recursive model, or TRM, with just 7 million parameters hits almost 45%. It's not just a little better, it's blowing it out of the water with a tiny fraction of the size. So how? How is that even possible? The secret is all in the design. See, a TRM isn't just a shrunken down big model. It works totally differently. It uses one small network that basically thinks about the problem over and over again. It makes a guess, then it looks at its own guess and improves it, step by step. So here's how that process works. First, it just spits out an initial answer. But then it gets into this loop. It thinks about the question and its own answer, updates its internal reasoning, and uses that to come up with a better answer. And then it does it again and again. So instead of one giant guess, it's a series of small, deliberate, and improving steps. And that right there is the whole point of this less is more idea. By basically teaching the model to think about the problem repeatedly, you can get way better reasoning with a tiny, tiny fraction of the horsepower. It's a huge hint that maybe intelligence isn't just about raw size, but about how you use what you've got. Okay, so that was about efficiency. Now let's switch gears to the second big challenge to the scaling idea. This one's not just about being smaller, it's about actually understanding what's going on inside these things. It's about zooming in. I love this quote from the folks at Distill. They compare it to the first microscopes. You know, when suddenly we could see this whole hidden world of cells. The idea here is the same. If we zoom in on these neural networks, maybe we can find a rich inner world instead of just an impenetrable black box. And what do we find when we zoom in?
we find something researchers are calling circuits. And these aren't just a jumble of wires. They are actual, understandable little algorithms that are baked right into the network. Think of them like tiny mini programs, each doing one specific job.
And this is where it gets really cool. By following these circuits, you can see how the AI builds up ideas. You can literally see a circuit for detecting a simple line, and then see how the network combines a bunch of those to build a curve detector. It's like building with Legos. And it keeps going until you have a complex circuit for a dog head that's made up of smaller circuits for an eye, a snout, and fur. All of a sudden, it's not a magical black box. It's an intricate logical machine. Okay, so we've got these two big ideas, right? Radical efficiency with recursive models and deep understanding with circuits. They sound pretty different, but are they really? Let's connect the dots. Yeah, at first glance, they seem to be tackling different problems. The TRM approach is all about the process, that deliberate step-by-step thinking. The circuits approach is all about the structure, understanding the little algorithmic building blocks inside. One is about how the AI thinks, the other is about what it's made of. But here's the key thing they both have in common. They're both a massive shift away from just building bigger and bigger black boxes and hoping they work. They're pushing towards designing AI, making systems that are smarter, more efficient, and this is the big one, actually understandable. So that's what's bubbling up under the surface. And it really makes you wonder, if the bigger is always better era is starting to show some cracks, what's coming next? What does this new focus on design mean for the future of AI? All right, let's wrap this up with the big takeaways. First, the idea that just scaling up is the only answer, well, it's being seriously challenged. Second, we now know that crazy efficiency is possible. These small recursive models can absolutely run circles around the giants. Third, we don't have to be in the dark anymore. We can actually look inside these AIs and decode the algorithms they're using. And all of this points to a really exciting future, one where we might build the next generation of AI by putting together these smaller, understandable recursive pieces. And that leaves us with the big question, the one that's going to define the next decade of AI. For so long, progress was just built on more and more scale. But now, we're seeing these new paths open up, paths that are all about elegant design and real understanding. So looking forward, will the next huge AI breakthrough be built, or will it be designed?